My name is Mr. Busacco, and today I wanted to teach you about Lesson 4, Basic Exponent Properties. Exponents at their most basic represent repeated multiplication. The way they combine or don't combine is dictated by this simple premise. Example 1. The following 4 steps are given to find the product of the monomials negative 2x to the 5th and 4x squared. We can take that and we can rewrite it in a different order. We can write it in these orders. Let's write down what the properties are that allows you to go from this given expression to what we have in step 1, from what we have in 1 to 2, from what we have in 2 to 3. Okay, so to go from this expression to step 1, all we've done is regrouped the factors that are being multiplied. That's an example of the associative property of multiplication. But then within those parentheses, to go from step 1 to step 2, I've changed the order. That's an example of the commutative property of multiplication. And lastly, I regroup again to put these constants together and these variables together. That's the associative property of multiplication. Now negative 2 times 4 is negative 8, and x to the 5th times x squared is x to the 7th. Over here, we see the question, explain why the final exponent on the variable is 7. And it is 7 because, just as we said earlier, exponents are repeated multiplication. So in reality, x to the 5th times x to the power of 2, called x to the 2nd or x squared, is really x being multiplied by itself 5 times, that's the x to the 5th, and x being multiplied by itself 2 times, that's x squared. And if you multiply this x to the 5th by this x squared, that can be rewritten as x to the power of 1, 2, 3, 4, 5, 6, 7. And so the shortcut for multiplying variables that have the same base is to add their exponents. But students and teachers can forget these basic properties used in simplifying the product of two monomials because we tend to pick up on the pattern of multiplying the numerical coefficients, that's the numbers in front of the variables, and adding the powers of the exponents without thinking about the commutative or the associative properties. And so let's speed up the process here and just go right to the answer. And in these examples, you can see in A, all we have to do is multiply the 5 by the 3 and the x squared times the x to the 6. Because those powers have the same base, we can add those exponents. So the answer would be 15x to the 8th. In choice B, we'd multiply the negative 2 by the negative 6. Remember, a positive times a positive is a positive, but a negative times a negative is also a positive. When you're multiplying, if the signs are the same, the answer is positive. So we would have 12, and again, the bases are the same, so we can add the exponents. I guess the trick here is to know that this x that you see right here, it's not x to the power of 0. It's x to the power of 1. We don't have to write 1s when they're exponents. So when you see a variable without an exponent, always remember that exponent is 1. So 1 plus 4 is 5. We have 12x to the 5th. Moving on to example C, 3 halves times 6. So there's a couple different ways you can do this. You could multiply the 3 by the 6 to get 18 and divide by 2 to get 9. Or you could do 6 divided by 2 first to get 3 and multiply it by this 3 to get 9. It's 9 either way. And now we can keep the x because that's a common base. They're both x's. And so we can keep that base and add the exponent. 9x to the 14th would be the right answer. And in D, oh, wait a second. This is being raised to the power of 2. Remember what something being raised to the power of 2 means? It means to multiply it by itself, not multiply it by 2. So when I see an exponent on the outside of parentheses, sometimes what I do is rewrite the thing on the inside that many times, in this case twice. And then 4 times 4 is 16, and x cubed, which is another name for x to the power of 3, x cubed times x cubed is x to the 6th. Okay, we can pick up the process here. Example 3, same thing, we just have more than one variable. So the 4 times 5 is 20. The 4 and 5, those are numbers, but because they're being multiplied by variables, we call those coefficients. We multiply the coefficients. And now we can add the exponents on the x variable. 3 plus 1 is 4. And we can add the exponents on the y variable. 2 plus 5 is 7. So the correct answer is 20x to the 4th y to the 7th. In B, we're going to get positive. Remember, a negative times a negative is a positive. So 8x to the power of 9. And y also to the power of 9. 8x to the 9th, y to the power of 9. And lastly, fractions, no big deal. We know how to multiply fractions. You multiply the numerators, 1 times 5, and you multiply the denominators. 2 times 2 is 4, and we leave it as 5/4. X times x squared is not x squared. Remember that first x has an exponent of 1. 1 plus 2 is 3. So x times x squared is x cubed. And for the same reason, y times y to the 5th is not y to the 5th, it's y to the 6th. So we have 5/4 x cubed y to the 6th. If you wanted to argue that that would be the same as 5x cubed y to the 6th over 4, I would agree. Okay, I think before we start this next example, it's worthwhile to remind you that when you multiply two numbers together, those numbers that are being multiplied together are called factors, and the answer that you get to that multiplication is called a product. Understanding those definitions is helpful because in the following examples I'm going to use those term names or those vocabulary words. One of the key skills we will need this year will be factoring expressions. That means if you were to start with, say, a product, can you decide what the two things were or what the two factors were that were multiplied together to give you that product? So we're going to concentrate especially on factoring out a common factor. To build some skills with this, consider the following problems. Example 4. Fill in the missing blank in each of the following equations involving a product such that the equation is then an identity. Identity just means that then the two sides are equal to each other. So let's not be confused by the word identity. It comes from the idea of identical. The two sides are the same. So, in other words, in this question, it's asking us, hey, if you have this product, what two things must have been multiplied together to get that? So, really, 2 times what other coefficient would be 6? If you can't just guess that, then you're doing 6 divided by 2, which is 3. I have to write a little bigger than the space that's provided here. And x to the 5th would be x squared times x to what power? Well, remember that we have to add the exponents on the 2x squared and the 3x to the missing power to get x to the 5th. So that exponent must be 5 minus the 2, resulting in an exponent of 3 here. So what did I do? I just basically did this 6 divided by 2 to get 3, and this 5 minus 2 to get 3. If I follow the same process here in B and C, I'll get 3. 12 divided by 4 is 3, and 5, because 8 minus 3 is 5. And lastly, in C, I will get negative 10 x. I could write x to the power of 1, but I don't need to. Why is it x to the power of 1? Because this is a 2 on this x squared, and this is really a 1, and 2 minus 1 is 1. And y to the 4th must be equal to y cubed times another y, and that's because 4 minus 3 is 1, and I don't have to write the exponent of 1 on that y. Okay, let's go back to multiplying, but the difference in these examples in exercise 5 is that we're multiplying not a monomial by a monomial. Monomial means one term. A term is a coefficient multiplied by a variable or variables. So this is a term, this is a term, this is a term, also known as a monomial, a monomial, a monomial. But here I have just one term, but it's being multiplied by two terms. So I have a monomial being multiplied by a binomial. No big deal. What we're going to do is we're going to distribute. We're going to multiply the 2x by each of those. So 2x times 5x is 10x squared, and 2x times 3 is 6x. We can even do a problem like this next example where we have 3 terms being multiplied by that binomial. There could be any number of terms on the inside. This 5x cubed can just be multiplied by any number of different terms that we might have. So 5x cubed times 2x squared is 10x to the 5th. 5x cubed times negative 3x would be negative 15x to the 4th. And 5x cubed times 6 would be 30x cubed. My stylus is giving me a little problem here. And so we get 10x to the 5th minus 15x to the 4th plus 30x squared. In example C, we're going to have negative 7x to the 4th plus 14x cubed minus 21x squared. Moving down to D, no numbers here, no constants, not a problem. We're going to multiply xy squared by x squared. But how do we multiply xy squared by x squared? Well, simply put, we just multiply the x by the x squared to get x cubed, and the y squared is just kind of tagging along for the ride. And lastly, xy squared times negative y squared. Well, xy squared is positive and negative y squared is negative. And whenever we're multiplying and the signs are opposite, the product or the answer to that multiplication problem will be negative. So I know I have a negative, and now I'm going to multiply the xy squared by just the y squared. I've already taken care of this sign right there. And xy squared times y squared is going to just be then x, which is tagging along for the ride, times y to the 4th. Because y squared times y squared is y to the 4th. Using the same ideas, we can, in this last problem, quickly get 6x to the power of 4, y to the power of 5, plus 3 x cubed y to the 6th minus 12 x to the power of 2 y to the power of 7. Now, to build your way up to factoring in later units, let's make sure we can fill in missing portions of products. Exercise 6. Similar to exercise 4, fill in the missing portion of each product so that the equation is an identity. That just means so that the two sides are equal. Again, let's not be confused by that word identity. No big deal. Okay, so we're going to use the same idea. We're going to ask ourselves, what can we multiply 4x by to get 8x squared? If that's not obvious to you, ask yourself, what is 8x squared divided by 4x? What is 8 divided by 4? It's 2. And what is x squared divided by x? It is just x, because when I add the 1 here and the 1 exponent here, I get 2. Moving on, negative 12 divided by 4 is negative 3. That's it. We're going to repeat the process for these other problems. Let's take a look at B. 7 divided by 7 is 1. I don't need to write the 1 down. X to the 4th divided by x squared is x squared. And I'm just going to keep going a little more quickly here. I'll have x squared minus 3x minus 4. Forgot the x there. I need to write that in. In C, I will have 2x squared. And that's it, because technically this y squared divided by y squared is 1. So I'd have 2x squared times 1, which is just 2x squared. So I don't need to show anything for the x squared divided by the x squared. And then I'll have minus 4x, y. And lastly, I'll have plus 7y cubed. In the last example, I'm actually factoring out this x minus 2 from each of them. So when I take this expression and divide away the x minus 2 that I see here, that I'm factoring out, this is divided away by that, and I'm just left with the 4x squared. And here, the x minus 2 is divided away again. That's divided away, leaving me with just minus 9.
There's no, plug into it. So I guess I won't be having one. Oh, just the lamps.
There's a plug over here, honey.
Oh, okay. We will in the corner. There's also a lot of times that we would get migraines. Amy and I maybe turn off the lights an awful lot. And, so we had candles, we had lamps on our desks and stuff like that. Is that a little?
Yeah. Well, there is a plug right over by Deb's desk, so I'm sure it'll reach. Yeah,
Okay.
I'm sure it'll
I'll just
reach.
leave it in the box right now.
Please press 1 to be removed from our list. If you would like to speak with a representative, please press 2. Thank you for returning our call. If we have called...
Do you still have their Mark's number? I don't have Mark's, I have Rick's.
It's not Rick the little guy, right? Rick Metzger is...
It's all one. Yeah.
What's up, bud?
Hey, we're just making videos.
You are?
Yeah, so everyone for the first unit, because it's all review. So, and we need to save time in this course, so the kids are just going to come in and do it by watching the videos of the review. So I just went and recorded the video. How's your summer?
Good. How about yours?
Amazing. I haven't been home hardly at all.
That's nice.
Yeah, we went to the Adirondacks for a week.
Mm.
And then 6 weekends away for Zoe to play softball.
Wow.
So that was big. And Luke did some performing. And we went to Taylor Swift in Washington.
Cool.
Yeah. And we've been looking at schools for Zoe. So it's been a really fun summer.
Isn't that amazing? I can't believe she's going to go to college.
I can't wait till she goes. I mean, I can't believe that she's going to college.
I hear
No,
you.
I don't want her.
I know, I get it.
I don't want her to go.
I totally get it.
So, how the boys?
They're good. They're going into 8th grade. They're going to take Algebra and Earth Science this year. Well, they're funny.
Yeah?
Yeah. They're testing for 2nd degree black belt next week.
Awesome.
Yeah. So they've been busting their ass.
Oh, I
They've been
know they work
probably
hard at
going 4 or 5 times a week to karate the last summer long. Just trying to get ready. Which is pretty cool. And then we went to Colorado for 10 days, which was really nice.
Yeah.
Visited friends out there.
Yeah.
Yep. So the people that they were like our family when we lived out there. They have a house right on a mountain. Like right on. It's really cool. They live there all the time. Like right on.
On the mountain.
Yeah. It's pretty awesome. So like we go there, we're like, oh, how do you even go to work? You know?
I do that.
But they work in the mine. They mine molybdenum.
What is? I think you just started.
Yeah, I know. Isn't that weird? I only know that word because of them. Molybdenum.
Molybdenum? What is that?
They call it Molly sometimes, but I guess it's
Is it Molly a drug?
it's a different one.
It's a different drug.
Yeah, this one, I guess, is like very valuable in electronics.
Mm-hmm.
It's some kind of metal that they use for electronic anything.
Mm-hmm.
So,
It sounds like what's known as a rare earth metal.
I think so.
Is that what it is?
I think.
Yeah, I want to look. How do you spell it?
I have no idea. MOLY something.
Oh, it's MOL?
I think it's MOLYB. Molybdenum.
Molybdenum came up.
Mhm. It's pretty cool. So yeah, they all work there, and their son, when we moved out there, their son was 3. He just turned 20.
Looks really cool. Oh yeah?
Yeah, so that was kind of fun. Yep. So we did that. That was pretty nice. Working on, or making a back. It was going to be just a porch, then it was going to be a 3-season room, now it's going to be an all-season room.
Wait, what?
We're not adding on, but we're changing a room behind our house, which is pretty cool. So we've been putting in windows and big French doors.
Sounds nice.
It's gonna be nice. We're gonna have a fireplace out there, but it's slow.
And Aaron's doing okay?
Yeah, he's doing really well.
Is he's not doing the work though?
He is doing the work.
Oh, he's doing the work.
Come on, you know.
I do know your husband.
Yeah, he won't let anyone do the work, ever.
But that's a waste of money.
Exactly. And it won't be exactly like you want.
Well, that's the biggest issue. He can
It
seriously
probably is.
because
he knows too much.
right, if someone comes over and he can do the exact same work and they don't do it the way he told them to do
Oh,
it,
he's
he'd be
gonna
like,
be pissed.
why
Yeah.
did you do that? I didn't
Right.
tell you. Whereas I'd be like,
Exactly.
wow, cool.
Exactly.
You just put a window in there.
Yeah, like he couldn't.
Yeah.
Well, say hello to everyone for me.
I will.
Give them
I will.
hugs.
I will. See you.
Alright, bye.
Oh, okay. What can you save it as?
I didn't yet.
Yeah, me neither, and I want to save it. And then I want to get out of here.
Yes. So, how do we see?
Oh. That's a little different than what mine looks like. So I have this little icon here that has a folder. This is like down. What if you go home? You don't want to leave, do we?
It's okay.
Will it still be there?
I think so.
It'll ask you to save it probably.
Probably.
So you say yes, and then they let you name it. Yeah.
Okay. So, unit?
Well, should we call it Algebra 2 first?
Yes.
Okay. So if everyone calls it Algebra 2.
Just put it all one word? No.
Oh,
I didn't make a capital A. Capital A?
Must be capitalized. It's a specific course.
Algebra 2. Unit. Are we going to do you want to do U1, L1 again? Or do you want to write out Unit 1, Lesson 1?
I'm fine with the abbreviation.
Okay.
Do you want to call it A2?
Why? I don't know. I'm even thinking we should do CCA 2.
Okay, let's do that.
Instead of Algebra 2.
Yeah. Let's go CCA2. I did all caps? Okay.
I did too.
All right. CCA2, then a space, and then unit U1.
Oh,
Okay.
1. Year, whatever. 4, 5,
Yeah.
4.
Yep. Okay.